Okay, today we are going to look at this question. It is actually from mathematical analysis. So whoever that is student of mathematical analysis will definitely know this question. We must have made it somewhere. At least, if not computing the limit, must have been asked to show that this sequence converges or is convergent. Okay. My interest here is in computing the limit, not necessarily showing that it is convergent, because the first part, which is showing that it is convergent, is a bit easier than showing that or finding the limit itself. So how do we go about it? Let's look at how we go about this type of question. Let's say limit solution. So for number 1, our an is greater or equal to 0 for all n greater or equal to 1. So again, an plus 1 minus an is strictly greater than 0 for all n greater or equal to 1. What does this mean? That an is monotone increasing. So let us call this b, 1b, this is 1a, then c will give us that an is strictly less than 1 for all n bigger or equal to 1. So an is positive, an is monotone increasing, and an is bounded above. Then from monotone convergence theorem, it says that every monotone increasing sequence that is bounded above converges. In fact, we know that every monotone increasing sequence has a limit, but in this case it is bounded above, therefore it converges. It converges to its supremum. The supremum may be 1 or 0. In fact, the limit of this sequence is in between 0 and 1. The limit of this sequence is in between 0 and 1. I cannot establish now that the sequence that it converges to 1, because why I can't establish that it converges to 1 is because I know that 1 is an upper bound, but I can't establish that 1 is the least upper bound. But if 1 is the least upper bound of this sequence, automatically the sequence converges to 1 because it is monotone increasing and hence converges to its least upper bound. Okay, let us look at our major work, which is the second part of the question. Question number 2. We are to compute the limit. Recall that an is nothing but sum k from 1 to n of 1 over n plus k. This is what we have. N is bigger or equal to 1. This is what we have as our an. This is nothing but sum k from 1 to n of n all over n plus k times 1 over k times 1 over n. So if this n cancels out this n, I will have the same thing that I have up there in the first one. And this is nothing but sum k from 1 to, okay, let me go to next page. Let me go to next page. This is really easy to see. But let's see. Okay, let's go to fresh page. So it is nothing but sum k from 1 to n of 1 all over 1 plus k over n times 1 over n. So this is actually what we define as an over there. This is our an. Okay, is this our an? Now consider this function f of x equal to 1 over x on 1, 2. Obviously f of x is continuous on 1 to 2 on this interval, and there, because it's continuous, it is Riemann integrable on this interval. So we can actually find the Riemann sum. Now let us try to find the partition of 0, 1. Pn is equal to 1 to 1 plus 1 over n, 1 plus k over n, up to 1 plus k over n, then up to 2. So now what then is the Riemann sum? The Riemann sum is equal to sum n from 1 to n of f of tk. This is k from 1 to n of f of tk, the mesh of the partition, where the mesh of the partition is just 1 over n. That's the mesh of the partition, and k is tk is taken from any sub interval of a of 1 to k minus 1 sk, just any small interval we pick in the partition. So what is this equal to? This is equal to sum k from 1 to n. What is our f? F of x is equal to 1 over s. So f of, okay, we will have f of 1 plus k over n dot 1 over n, which is the mesh of the partition, and that is equal to sum k from 1 to n of 1 all over 1 plus k over n dot 1 over n. So if we look at this now, we'll see that what we have here is nothing different from what? An. This is exactly our an, what we are looking for. And so we now find the limit as n goes to infinity of an. So now limit already we know now that limit as n goes to infinity of an is equal to limit as n goes to infinity of sum k from 1 to n of 1 all over 1 plus k over n dot 1 over dot 1, everything all over 1 over n. So but what is this? This is nothing but integral from 1 to 2 of 1 over x dx, and this is equal to lim 2. So that is the sequence. Of course, lim 2 is in what? 0, 1. Remember, all the terms of this sequence is greater or equal to 0, and 1 is the lower bound. So the supremum of this sequence is lim 2. Thank you for listening to this video. Endeavor to subscribe to my channel so that you'll be among the first to always receive the new videos I'll be uploading, so that whenever I upload any new video, you must be able to get it, see it on time, and then work with it when applicable. Thank you for watching. Like and share this video. Thank you so much for watching.